Okay. Good morning, ladies and gentlemen. Welcome to RakutenTechConf2015, and the upcoming session is Cloud Mobile Backend. Please welcome our speaker, Kanyo from Rakuten Mobile Service Group Smart Devices Technologies Department. Yeah.
Thank you very much. Welcome to Rakuten Tech Conference. I'm really honored to be one of the first speakers. So I hope that you enjoy the session. So my name is Kanyo. I work for Smart Devices Mobile Service Group, and today I'll talk about Cloud Mobile Backend. So if you have a big dream, if you have a big project, if you need to innovate, you need to see a little bit further. You need to see a little bit in the future. So one of the best options doing that is to stand on the shoulders of giants. So today I'll talk about one new modern giant, the public cloud, and especially Microsoft Azure. So Microsoft Azure comes with unmatched scale, both in computer power and global spread. And you can use the public cloud in different ways, but today we talk mainly for a platform as a service. So platform as a service is a collection of services provided by Microsoft that allows application developers very easy to develop new applications, run them on the public cloud, and manage them. On the other hand, Microsoft as public cloud provider creates these services and manage them and maintain them completely. So application developers shouldn't care so much. And today I want to walk you around one of the projects that we are developing with my department and team. So one of the first steps for our users is to come to a web portal. This web portal is hosted in Azure Web Apps. Azure Web Apps are one of the best ways for hosting websites and APIs in the public cloud. It comes out of the box with auto-scale, as well as very quick deployment. So basically you can have your website for 1 minute published to the cloud, as well as there is support for multiple platforms. The next step for our users is basically they need to log in the website. However, to manage username and password is a very difficult job if you want to do it the right way. That's why we use another service by Microsoft called Azure Active Directory, which is equivalent of the Active Directory but in the cloud. So what's going on? When the users press the login button, we take them to a page in Azure that is completely managed by Microsoft, implement the best security practices, and the user basically perform the login operation. If the login is successful, they return to our website. And when they log in our website, they start to modify the data. And this data is persisted in Azure SQL database. So this is a database like the usual SQL. The only difference that it's managed as a service by Microsoft. This means that you create the database only for minutes. After that, you have access to manage it, but all the maintenance for it is responsibility for that is only for Microsoft. So our mobile clients access this database via APIs. So for the APIs, we again use Azure Web Apps. But here we have to solve another type of questions. So how we manage the access to the APIs, how we distribute them globally, and also how we make it easy for developers to consume them. So for these problems, basically we use another service from Microsoft. So the idea here is that I'm introducing one by one the services that we're using by Microsoft, so you can see like how much we rely on the services that are coming by the cloud. So returning to the API management, this is basically the API proxy that sits in front of our APIs. So this allows us to basically help to have a single API endpoint, and as well as to control the traffic that is going to our APIs. And we also can modify the response in the requests for these APIs with the help of API management. However, API management adds additional complexity to our architecture. So we want to know what's going on this level. API management has built-in reporting, but it's very high level. Actually, in our department, we want to have very fine control on each request and each response for each of the APIs. So for that, basically, we create multiple events that we send to event hubs. Again, service from Microsoft Azure. And event hubs is basically a giant queue. you can send multiple events. Actually supports millions of events per second because it's designed for IoT scenarios. So we are sending these events. Basically, we have the capability to create these events with custom code on API management level. So as you can see here, on the first line, we are defining variable that after that will be available from the context of API management. And below, we are basically creating a JSON object and populating few properties for this JSON object. Then we are converting this to string and we are sending to Event Hub. So we have like a full control how the events that we are sending to Event Hubs will look. So after that, we can work with them. Okay, so when we send the events to Event Hubs, basically they're here. They need to be processed. So we have various options in Azure, but one of the most interesting one is Stream Analytics. So Stream Analytics is the way that you basically process events in real time. So if you want to know how your system behaves in this moment, not when the data go to the database, but exactly in this moment or in very short time window, let's say 5 seconds or 1 minute, Stream Analytics can give you that thing. So for the people who have experience, Stream Analytics is similar to Apache Storm. And also we have like an advanced language similar to SQL that allows you to make real-time processing. Okay, and from Stream Analytics, we basically provide output for several different Azure services. So the first one, we generate visual reports. So for example, if our business want to know how our APIs are performing, they can go and very quickly see what are the response times of our APIs in Power BI. The second one, Logic Apps, basically allow us to trigger a workflow in the cloud. So if there is some problem with our API management, we are able to trigger a workflow, and you'll see later in the demo, I'll be getting emails when the problem starts. So I can jump in and with our team, we'll be able to fix the problem. And the third option here is basically we'll archive a lot of these events. So later we want to analyze them and understand what was going on with the system. Okay? And when we're talking about archive, you can imagine that when we have like millions of calls per hour and tens of millions of calls per day, analyzing the logs is a very difficult job. So that's why we can employ and use Azure for big data processing. Actually, Azure has a very, very interesting big data services. So this is one of them. So basically what we'll do here, we'll take the archive, which is our input storage blob. After that, move it with a data factory, which is basically data moving and transformation service, and we'll move them to data lake. This is a huge store, basically infinite, because the size of the files that can store, it's really, really large. And also on this layer here, basically we have analytics jobs that we can process big data in SQL and C#. And this is very important for my team because we are primarily .NET developers. But on Azure, you can mix and match the data store with HDN sites and other big data processing systems. So this is one of the advantages of Azure. It's getting more and more open platform. You have more and more options to pick and choose the best thing for your solution. And basically, we go very quickly over this architecture, but I want to focus your attention on the big red rectangles. The first one, that it's labeled real-time processing. Basically, this gives information for your system real-time. So you know what's going on exactly now with your system. You shouldn't wait when somebody go to the database and try to dig up. And the bottom one is actually the batch processing. Here you have your data at rest. So everything is archived and you are able, by going to this layer, to answer complex questions that your business asks you for the behavior of your APIs, let's say today, last week, last year, and so on. So there was a lot of talking, but let's see how this looks in practice. So I recorded a short video that I'll walk you through the process. So first, we generate a lot of traffic for our API. Basically, here we have a load test with 10,000 requests running against our API. Next, we'll try to see how this performs on the API management level. So you see, this is API management level, and we start to get a traffic. Currently, we get around 400 requests for API management. I'll fast forward a little bit, and now we'll get around 3,000 requests from the 10,000 that we configured in the beginning. Okay, this is fine, but as you can see, maybe the font is a little bit small, but we don't have so much information. Basically, we have like a very few details that we know about our API responses. That's why we need to go to Event Hubs. This is the dashboard for the Event Hubs. So the dashboard, it's a little bit, needs more time for refreshing. That's why I'll fast forward a little bit so you can see that the requests are coming slowly. So soon we have like a first 3,000 requests recorded. So these messages already arrived at the Event Hubs layer. The next step is the stream analytics or real-time processing will start to work with them. And we'll see how they are processed on our visual dashboard or graph dashboard, Power BI. So this is our Power BI. We can see here we're collecting information about the response time. The problem that we try to solve, we want to see how our API performs and what are the typical response times. So this is breakdown on the response times. And we have few very popular response times. So for example, you can see here, this is 31 seconds. We have already 15,000 requests that took 31 milliseconds. This is another one that took 46 milliseconds, 25,000 at the moment. This is another one that basically 64 milliseconds, 11,000 requests with that. And this is 73 milliseconds, 10,000 requests. And the good part for this is that this dashboard presents information like a real time. So now what we'll do, we'll basically refresh this dashboard. Now we're checking 46 milliseconds, currently 25,000. We refreshed, and now we go and check again how many requests we have for the 46 milliseconds. And this will grow with around 500 requests because the load test is keep going, so we can see what's happening. This is the second flow. We are archiving now the data. This is basically our storage. And here we moved our request and response data to storage, which is basically files in the cloud. And we have a structure that is based on the date. This was recorded yesterday, so it's around 10 o'clock UTC. And this is how our log looks. Of course, there are a lot of entries, and the load test continues to work, so everything is tracked real time. Now we try to refresh because we want to see what will be the current state of these logs. And we'll preview how one request and response is basically tracked in our system. So first, let's look how one request looks. Just a little bit time. And this is how one request looks. The font is a little bit small, but what we record is the application ID, application bundle, the IP that the request come from, and also very important, this is the message ID. So each request and each response have a message ID, so we can track like do we have a successful request for response? And this is the response. The difference here is that this time we have a response body, and also we have response time. So for us, the response time is very, very important because we want to tell to our business unit like how good is our API on API management level. So now we go to the next phase. Basically, we want to analyze all this data with big data. The current solution that I'm using works very well with comma-separated values, so I keep one more data set that has comma-separated values. So, and the other difference is that we only track here the responses because we're interested in the response time. And as you can see, this is the same data. Currently, in the file, we have around 9,500 rows from the 10,000 that we configured. But as you can see, since the load test is still going, we are still getting updated. Oh, the load test finished. Yeah, this is done. So now we need to refresh the file and basically to confirm that all of our responses are recorded in the system. This is also very important just to clarify that your system is working as expected. So now we need to refresh this file. And this time we have around 10,001 rows. One row because the first row is actually the names of the columns for this file. Okay. So we confirm that the system works as expected. All of the responses are recorded. So now we can have like a valid big data processing and big data insights. So now we move the data file, if you remember from earlier, to data lake. This is our big data store. So our file keeps the same folder structure. The file looks like this. We have a small snippet that shows that everything is as expected. We have the same data basically that you saw before. We have few columns that are empty, but they're related mainly for the request, tracking IP addresses. Now we are interested more in the response time. And this is the interesting part. This is the big data query in the new language called useSQL that allows us basically to make a big data processing with data lake, the new service from Azure. So we have like three main parts. The first part, we are extracting the data. This part is extracting the data from data lake, from the file that we already previewed with you, mapping all of the columns that are already defined, and extracting with built-in comma-separated value extractor. After that, we're actually selecting the values that we're interested in, and this is the important role. Here, we're making average on the response time, grouped by application ID and platform name. And the last step is to output this data to a file so we can see what is the result of our processing. So let's run that thing. First phase we will be preparing. So here all the plan for the execution of this big data job will be done. The next step will be basically queuing. Now we are waiting for free resources to compute our job. And finally we are running the job. So it takes some time. And actually, we'll see real performance when we're working with terabytes and petabytes of data. But just to keep the demo simple, we'll go with this data. So it took a minute and a half. Actually, processing time was around 1 minute, and the other was preparation. So now let's see what is the output. The output is basically the average time for our API, average response time for our API for this application. So it takes around 59 milliseconds for our API. To get response by the API management. We can get a little bit more data if we see the same job in Visual Studio. So this is the plan of the job execution, and you can see some of the metadata here in a more structured way. So actually this is the execution result. This is our file. This is the process that we have. Usually you see many blocks when you work with more complicated tasks. And also we can change the view. So see how many data we read, how many data we wrote, and also what was the input throughput and output throughput. Another interesting part, if we click in the middle of this rectangle in the middle, we will see exactly the steps that we will perform by our data lake analytics jobs. So if we are interested and if we see some problem, we can go deeper and see and try to add optimization so our jobs perform better. And we have one more workflow to cover. And this workflow is basically when we have exception on our API management level. I want to know like what happened, and if it's something serious, we need to go and fix it immediately. So exceptional API management level means that our API will not suffer, but our tracking mechanism maybe won't be as expected. So let's see what we have here. This is logic app. So the logic app basically have actions and triggers. Currently, this logic app has okay, here. So the logic app basically has triggers and actions. So the trigger is when we have a message on a service bus queue. So we have a message over there, and we want to send email. So let's simulate how this looks. I'll send a API call that will basically perform that will cause exception. So here, this is how the logic app looks. The logic app have the trigger. This is the trigger, and this is the action. So the trigger, if we have message in a service bus queue, we want to send an email to the user. In that case, this is my email. So let's see what will happen. Now I perform several API calls that will result basically in exception. And very soon we should get an email based on for this exception. So it takes a few seconds, but in the end the mail comes. The font is a little bit small, but what we get the whole JSON object. And the interesting part here is that we have like the exception message, so we know what happened already. We have the message ID, so we can dive a little bit deeper and understand what happened. So with that, we have like a full coverage of our real-time scenarios, and also the big data and more deeper analytic scenarios on the persistent data that we have. So we are looking for people. If you're interested in cloud, if you're interested in mobile, please don't hesitate and contact us. We have a lot of openings, so please check our website. And if we have time, I think we can get a few questions. Thank you very much.
Any questions?
Yeah, very nice presentation.
Thank
Congratulations. Yeah, just a question related to the tool that you use in order to simulate the 10,000 events.
Yes, this is Visual Studio. Visual Studio, and you have to have Enterprise Edition, but it's very easy. You can run this load test locally. These tests are run locally from my machine. So this is one opportunity. Another opportunity is to use Azure. So then Azure can basically simulate a lot of code. So usually when we release a new API, we go over load testing with Azure, and we can configure 10,000 requests per second, because this was like a 10,000 requests for a long period of time. But potentially you can go very high scale with the help of Azure. So highly recommend. Very good tool. Yeah.
If I can make just one more question related to the hub.
Yes.
So you said that all the events go to the hub.
Yes.
Is that a custom application or it's in Azure?
No. I think maybe I didn't make it. All these applications that you see here, all these are services that are managed by Microsoft. So Event Hub, the message broker, Event Hub is one of the core services that they provide. Real time processing. The only custom thing that we have here are on the web, the portal and the API, and a little bit on the API proxy. Everything else, it's basically integration on the existing services. Of course, you need some customization, as you saw, like queries, but all the scale is managed by Microsoft. So, for example, we have a very good team in Rakuten, but if we need to build all that thing alone, maybe it will take us months or years at that scale. Microsoft basically use their knowledge that they have for their internal services. For example, this thing here, the data lake, was their internal project for around 15 or 20 years. So they're bringing this knowledge outside. And they said that in their internal copy of data lake, they keep 5 copies of internet, right? Internet, everything. So their engineers can basically make smart decisions, making queries. So this is very important. Microsoft step-by-step opening themselves, giving access to the people, to their internal system that are really, really high scale. And we try to benefit as much as possible and try to advance our business. We want just to add our application logic. We don't want to build core services. We just want to give benefit to the business mainly. Yeah. Thank you.
Any more questions? Okay, if no question, this
Thank you very much.
session.